In this lecture, we will connect an Android app to Firebase Authentication and Cloud Firestore. The example we will use is a simple book review app. A user first signs in with an email and password. Firebase Authentication gives that user a unique ID, or UID. Once we have that UID, we can store data in Firestore under that specific user. In this example, each user has one profile, such as name, age, and city. The user can also write many book reviews. Each review has a title, author, rating, and comment. The important idea is that authentication and database storage are connected. Authentication tells us who the user is, and Firestore stores data under that user's path. So, after login, each user can store one profile and multiple book reviews, and the app can keep those records separate from other users' records. Firestore stores data using collections and documents. A collection is like a group of related documents. A document is one record inside that collection. Inside a document, we store fields, and each field has a key and a value. The important pattern in Firestore is that paths alternate between collections and documents. For example, we may have a user's collection. Inside that collection, there is a document for one user, such as ABC123. Inside that user document, we can store fields like name, age, and city. If that same user has many reviews, we can create a subcollection called reviews under the user document. Inside that reviews collection, each review is another document, such as review A or review B. So the full path might look like users/ABC123/reviews/review A. This means, go to the user's collection, find the user document ABC123, then go to that user's reviews collection, and then read or write the document review A. This slide is a map of the main Firebase classes we will use in Android. We can group them into a few categories. First, for authentication, we use Firebase Auth and Firebase User. Firebase Auth is the object we use to sign up, sign in, sign out, and check the current user. Once a user is signed in, Firebase User represents that signed-in user. From that object, we can get the user's UID. Second, for Firestore, we use Firebase Firestore, collection reference, and document reference. Firebase Firestore gives us access to the database. A collection reference points to a collection, such as users or reviews. A document reference points to one specific document, such as one user profile. Third, when we read data, Firestore gives us snapshot objects. A document snapshot represents one document that was read. A query snapshot represents the result of reading many documents from a collection. Finally, security rules are written in Firebase console, not in Android code. The Android app requests access, but Firebase rules decide whether that request should be allowed. Authentication is the first step before storing per-user data. The user can either sign up to create a new account or sign in to use an existing account. In both cases, the Android app sends an email and password to Firebase Authentication. If the sign-up or sign-in succeeds, Firebase gives the app a Firebase User object. From that user object, we can get the UID. This UID is very important because it becomes the key that connects authentication to Firestore. For example, after login, if the UID is ABC123, we can store that user's profile at users/ABC123. We can also store that user's reviews under users/ABC123/reviews. So the app does not need to invent its own user ID. Firebase Authentication gives us a stable UID, and we use that UID to organize the user's data in Firestore. This table summarizes the main authentication methods we need. The first method gets the authentication object, Firebase Auth.getInstance. This gives the app access to Firebase Authentication. The next two methods are for account creation and login. Create user with email and password, creates a new user account. Sign in with email and password, signs in an existing user. After that, we have methods for checking and using the current signed-in user. Get current user returns the current user if someone is signed in. From that user, get UID gives us the UID, and get email gives us the email address. Finally, sign out signs the user out. So this table covers the full basic authentication cycle: get the auth object, create or sign in a user, retrieve the user information, and sign out. This example shows the authentication logic in Java. We should read it in chunks, not line by line. First, the code creates a Firebase Auth object and defines a test email and password. This gives us the basic information needed for a simple authentication test. The first method is the sign-up method. It calls create user with email and password. If the task succeeds, Firebase has created a new account. Then the code gets the current user and prints the UID to logcat. If the task fails, the code logs the error. The second method is the sign-in method. It uses the same email and password, but this time it calls sign-in with email and password. Again, if the sign-in succeeds, the code gets the current user and prints the UID. The final method checks the currently signed-in user. If the user is not null, that means someone is already signed in, and the app can use that user's UID. In a simple class activity, students can first call sign up once, and later call sign in to test the same account. Now that we know who the user is, we can write data to Firestore. This slide shows two types of write operations. The first write is the user profile. Since each user has one profile, we can use the UID as the document ID. So the profile goes to a path like users/UID. For example, if the UID is ABC123, the profile is stored in users/ABC123. Here, we use set, because we already know the document location. The second write is a book review. A user can have many reviews, so we store those reviews in a subcollection under the user document. The path is users/UID/reviews. When we add a new review, Firestore can generate a new document ID for us. For that, we use add. So the simple rule is, use set when you know the exact document path, such as the user profile. Use add when you want Firestore to create a new document inside a collection, such as a new book review. This table summarizes the write operations. The first group is setup. We get the Firestore database object using Firebase Firestore.getInstance. We also get the current signed-in user using Firebase Authentication, and then we get the UID from that user. The second group is data preparation. In Java, we commonly use a map string object to represent the fields we want to write. For example, we can put title, author, rating, and comment into a map. The third group is path construction. To write the profile, we build a document path like db.collection, users.document, UID. To write reviews, we build a collection path like db.collection, users.document, UID.collection, reviews. The final group is the actual write. We use set to write the profile document and add to add a new review document. If we use add, Firestore generates the document ID, and we can retrieve that ID afterward. This code writes both a user profile and a book review. Again, we should understand it in logical chunks. First, the code checks whether a user is signed in. It gets the current user from Firebase Authentication. If the user is null, the method returns early because we do not know where to store the data. Second, the code gets the UID and creates a Firestore database object. The UID will determine the user-specific path in Firestore. Third, the code creates a profile map. This map contains fields such as name, age, and city. Then the code writes that map to users/UID using set. Fourth, the code creates a review map. This review has fields like title, author, rating, and comment. Then it adds that review to the user's reviews subcollection using add. The main idea is that the UID controls the location of the write. The profile and all reviews go under the signed-in user's path. Reading from Firestore has two common patterns: reading one document and reading a collection. If we want to read the user profile, we read one known document, such as users/UID. Firestore returns a document snapshot. From that snapshot, we can extract fields like name, age, and city. If we want to read the user's reviews, we read a collection, such as users/UID/reviews. Firestore returns a query snapshot, because the result may contain many review documents. Then we loop through the documents inside that query result. Each document in the loop represents one review. So the key distinction is this: one document read gives us a document snapshot, a collection read gives us a query snapshot, and then we loop through the returned documents. This table summarizes the main read operations. The first group is the same setup as before. We get the Firestore object, get the current user, and get the UID. The second group builds the paths. For the profile, we use users/UID. For the reviews, we use users/UID/reviews. The third group performs the reads. To read the profile document, we call get on the document reference. To read the reviews collection, we call get on the collection reference. The final group extracts the values. From a document snapshot, we can call methods like getString or getLong to retrieve individual fields. For a collection result, we loop through the documents and extract fields from each review. This table is useful as a reference when students are writing their own read methods. This code reads the profile and then reads all reviews for the signed-in user. The first chunk checks authentication. It gets the current Firebase user and returns early if there is no signed-in user. This is important because we need the UID to know which user's data to read. The second chunk reads the profile document. The code goes to users/UID and calls get. If the document exists, it extracts fields such as name, age, and city, and prints them to logcat. The third chunk reads the reviews collection. The code goes to users/UID/reviews and calls get. Since there may be many reviews, it loops through the documents in the result. For each review, it extracts fields such as title, author, rating, and comment. So this example shows the two most important read patterns: read one known document directly, and read many documents by looping through a collection result. This final slide is a practical setup checklist. Before the Android code can run, we need to configure Firebase and Android Studio correctly. On the Firebase console side, we first create a Firebase project. Then we register the Android app by giving Firebase the app's package name. Firebase then gives us the Google Services.json file, which connects the Android app to the Firebase project. We also need to enable the Firebase services we plan to use, such as Authentication and Firestore. On the Android Studio side, we place Google Services.json inside the app folder. Then we update the Gradle files. At the project level, we add the Google Services plugin. At the app level, we apply the plugin and add the Firebase dependencies, such as Firebase Auth and Firestore. After those steps, we sync Gradle and build the project. If the sync and build are successful, then the app is ready to use Firebase Authentication and Firestore from Java code.